So limit of the square root of f of x as x approaches a. This can be calculated as the square root of the limit of f of x as x approaches a. And this is swapping operators. This is what I need to do right now. I need to swap the operators. What operators? This one with this one. So now the inner operator is not the square root, it's natural log. The inner operator is not power n, but it's natural log. So I will swap the operators under continuity. This is a continuous function, this is a continuous function. So then from here, I swap the operators and I have natural log of limit of y. So the limit as x approaches 0 from the right, from our x raised to the square root of x, because that's what the y is. And now I'm going to ask you, log of what is 0?
One.
Of 1. So therefore this limit, we can say now with no doubt that it happens to be 1. So this must be 1. There is no other way. Why? Because only natural log 1 will be 0. There is no other number, but natural log 1 is 0. So sorry about that, I had an error here. This is 0 raised to 0. We cannot conclude. Okay, so please remember, any number raised to 0 is indeed 1, with the exception of 0. 0 raised to 0 is not 1. It's an indeterminate case, and we have to worry about it.
So it just happened to be 1 this time.
It just happened to be 1. By chance. Exactly. We're going to work on other problems so you can see this step-by-step procedure again. Okay, let's look at another one, like 65. 65. Limit as x approaches 0 from the right again, and it's 4x plus 1 raised to cotangent x. Yes, it's not friendly, but we will decompose it step by step. So let's see, where is this going?
1.
Perfect. Now let's discuss cotangent. Cotangent is 1 over tangent. When x approaches 0, where is tangent alone going?
Is it 0?
Yes. And I have 1 over 0 from the right, positive. 1 over 0. Remember the graph? We just talked about it. 1 over x. Where is this going?
Positive infinity?
Yep. So the indeterminate case is another cumbersome situation. What did we say we had to do in the first step? We named the function, right? What do we do in the second step?
Log on both sides.
Very good. What do we do in step 3?
Apply limit to both
Very good.
sides.
Yes, as x approaches 0 from the right, from natural log y, limit as x approaches 0 from the right, from cotangent x times natural log of 4x plus 1. Good. Okay, we know that this, we already said it's going to infinity. We know that this, you already told me it approaches 1, so that means that this will approach 0. Much better than the power, because I know infinity times 0 is not a big deal. It's easy to manipulate to change it into either 0 over 0 or infinity over infinity. What do you recommend we do? How do I manipulate this function a little bit to change it into potentially this or this? Any suggestion?
Change it to cosine.
Just
sine over cosine. Oh, 1 over tangent.
exactly. Cotangent is 1 over tangent. Very good. And now I know that this is already, it's 0. And I know you already told me that tangent when x approaches 0 is 0. Yay! Just a simple thing. Cotangent is 1 over tangent. Okay. So now I can differentiate top and differentiate bottom. So then limit as x approaches 0 from the right. Can anyone give us the derivative of the top and the derivative of the denominator?
So 1 over 4x plus 1 times 4.
Excellent. Anyone gives us a derivative of tangent?
Secant squared x.
Excellent. Perfect. So now let's try again. Where is this going? When x approaches 0. Remember, secant is 1 over cosine. Where is cosine going when x approaches 0?
1.
Excellent. So then the whole thing is 1. Perfect. Where is this going? 4 over 4x plus 1 when x approaches 0.
4.
Excellent. So then what is this limit of the natural log equal to then?
4.
That's it. In step 4, we copy the beginning and we copy the end. And now what do we do in this step? We are ready to
Swap the operator.
very good. So this is equivalent to, what is the base of natural log? I don't see any base.
E.
E. E to the 4th power equals this. So limit 4x plus 1 to cotangent x as x approaches 0 from the right equals e to the 4th power. You did not expect that 1 to infinity will reach this. If you say that you did, I will not believe you. So one more time. We have natural log after we swap the operators because everything is continuous. Cotangent around 0 is continuous. 4x plus 1 is continuous. The function composition is continuous. Otherwise, we can't do this. I swap the operator and the operators, and I'm asking myself, natural log of what is 4? It has to be e to the 4th. 4 comes in front. Natural log 4. Natural log e is 1, so I get 4.
I had to ask, why was the cotangent equals to infinity as x approaches 0 from the right?
So this approaches 0. When x approaches 0 from the right, this is 0. Even from the left, it's still 0. So 1 over 0 is either infinity or negative infinity, by definition, or d and e. But this is 0 from the right. 1 over 0 from the right is this, infinity. It's the same with the function 1 over x, when x approaches 0 from the right. So this function is this function.
Understood, thank you.
Better?
Yep.
Okay. Do you think we need another example with powers, or we move on? Are we comfortable with the steps for powers? Any questions? So one more time, should we choose one more or we move on? You may be saying something, but you may be muted.
Personally, I'd say we can move on.
Okay? Well, let me know. You can stop me anytime. So I'd like to continue. And the next section is graphing. Again, what we just did last time. So we are just looking at more functions. But here I would like to talk about holes and asymptotes first, and then we choose other examples. Asymptotes like vertical, horizontal, and slant, also called oblique. Of course, vertical means this, horizontal means this, and what is slant or oblique? This, or this. Okay? So let me give examples. And I'm going to try and find one quickly, or just make one up. I'm going to make one up. So here it is. F of x equals x to the third plus 1 over x squared plus x. So first of all, this is a rational function. With degree at the top, degree 3 in the numerator, and degree 2 in the denominator. By definition, any rational function, pure. How will a non-pure look like? Something like the square root of x, x plus 1 over whatever. That's not a rational function. So a pure rational function has a polynomial at the top and another polynomial in the denominator. As long as the degree of the top is by 1 unit larger than the degree of the denominator, exactly by 1 unit. So the top has degree n and the denominator has degree n minus 1. This function will not have, does not have a horizontal asymptote, no, but slant asymptote. If the degree is 10 and degree 9, no horizontal but slant. The degree 7 and 6, no horizontal but slant. Degree 3, degree 2, no horizontal but slant. Of course, you may still have vertical, but no horizontal. So there is no function, no rational function that has horizontal and slant at the same time, either or. And the only one with slant is the one with degree n and degree n minus 1 in the denominator, exactly by 1. Okay, so here's an example. So for such a function, here the question is, show everything. Table, asymptotes, increasing, decreasing, concavity, inflection points, anything and everything, and then graph. Okay, I'm looking at this function. What will I have to do first? I'm given this function, I'm given any function. What is the first thought? Always the first thought. Or maybe you can say two. Yes. Say it again, sorry.
Differentiate.
No.
Oh,
So
simplify.
Excellent. Factor, simplify, and domain. I don't care what the function or what the problem is all about. I do care, but you know what I mean. I have to factor if it's possible. I have to simplify if it's possible. And then my next thought is domain. These are my first concern always. Okay, now I have to remember how to factor the top. Because if I don't remember how to factor the sum of cubes, then I make the whole thing more difficult. Anyone remembers how to factor the sum of cubes into a binomial and a trinomial? So let me refresh your memory. A to the third plus b to the third is a plus b. A squared minus ab, not 2ab, plus b squared. Of course, if I have minus here, then I have minus here, but of course I have to have plus here. So therefore, x cubed plus 1 is x plus 1, x squared minus x plus 1. Very important to remember. The sum and difference of cubes. Can anyone address the denominator now?
Quick question.
Yes.
Would the plus b change to a minus b squared? And the sum of
Here,
would that change to a
this
minus?
is
always?
fixed forever,
So it's always going to be plus there.
always. So the sequence of signs is plus, plus, minus. This doesn't even matter. It's always the same. Or minus, minus, plus.
So at the bottom be x plus x. Oh no, x plus 1.
Very good.
That one's just a simple one.
Good. Yes, that's just factoring out x. Do not simplify. You cannot simplify before you state the two restrictions. Because if you do simplify before you state the restrictions, your domain will be incorrect. So what are those?
0 and -1.
0 and -1. And only now I can do this. Good. So I get my table going. Negative infinity, -1, 0, infinity. I don't have anything to write here. That's why I'm doing this. This factor completely disappeared. Whole. This factor did not disappear. X equals 0, VA. The simplified form of this function is x squared minus x plus 1 over x. I like this because I can separate it into 3 fractions. X squared over x, and I get x, minus x over x, and I get 1, plus 1 over x. I will always do this if the denominator is one term. Why? Because everything I do will be very simple when it comes to the derivative. Okay. So at this point, I have to find these limits and identify whether there are x and y intercepts. I cannot plug in 0, so there is no y-intercept. Done. And when I try to find whether f of x is 0, then the numerator has to be 0. But this will never have real solutions. So I can come back here. This piece coming from the sum or the difference of cubes will always have imaginary solutions. No real solutions ever. Now, if this is power 6 and I get something else here, something else could happen. But every time the trinomial comes from the sum or difference of cubes, this will never have real solutions. So don't ever waste your time. We can write a quadratic formula and you see what happens. 1 plus or minus the square root of 1 minus 4ac over 2a. Not real. This is -3. So there are no x-intercepts, but I have to determine these limits. Good. So let's use the limit. So let's start with -infinity. X approaches -infinity from x squared minus x plus 1 over x. So we know where the numerator is going, of course, infinity, because this dictates these are too small. Of course, infinity or -infinity, it's not important, but it's L'Hopital's rule, cannot be difficult. I differentiate the top, 2x minus 1, I differentiate the denominator, oops, I get 1. When I plug in again, I get -infinity. So this is done. In the same way, I can write it again, but for x approaches infinity, it's the same thing. I didn't use -infinity or infinity, so this will be positive infinity. Okay, so to the left and right of the whole, I will just plug it in here. It's easier, right? Let me write it. So the limit